Well, greetings everyone, welcome back to Rob's workshop. So I suppose I'd better finish this thing off. Sit rep, the webs and machines to thickness. The radius on the top here is also finished. Apart from that, the ends, the main journals have been roughly turned, they're still way oversized, and I've faced off these two ends here. Lots of metal to come off yet. I think what I'll do first, I'll set the crankshaft up in Lathe, and then I can use the digital height gauge to mark sanity check lines where the webs hopefully will end up. I'm only going to use them as guidelines. I certainly won't be machining purely by the lines alone. I'll be measuring everything as I go along. So that's the first job. Mark the lines on the crankshaft. Well, that didn't take very long. See all my little marks there. I've been having to think about this, best way to approach this. I've got quite a bit to take off the center journal area there, which at the moment is still rough casting. That's going to batter the life out of the tool that I've ground to turn this center journal. So what I think I'll do is, hope I can get away with it, I'll leave it in the collet block and machine away. I've got an old end mill that I'm not too worried about. I can just cut away most of the material close to but not touching the lines, but at least I'll be under the skin of the casting, and it'll hopefully be less drama for the high-speed steel tool that I've got ready. Yeah, I'll try that and see if that, it's a bit of an overhang, but I might get away with it. I'll try it anyway. Right, as you can see, I've dispensed with the square collet block idea. Instead I'm using the rotary table, as you can see. Yes, I know there should be tailstock support here, but I ain't got one, though it is on my shopping list. Final cut, and we're done with this machine. There's a bit of an overhang as you can see, but what I did was I machined that face, the far face, first, and then flipped the crankshaft around the other way to machine that one, so that the overhang factor was minimised, shall we say. Okay, take this thing out now and we're done. Right, before I go to the lathe, I'll show you what I intend to do. I want to position the lathe tool in the center of this section here, so I'm going to touch the tool off on one side of that crank web, and on that side use the half function on the DRO, which will give me the center point. I want to work from the center outwards. So having got the center point, the tool is exactly 200 wide. The width required is 503, which will give me a small clearance over the bearing that will eventually sit in that place. So the difference is 303, divide that by 2. So theoretically I need to move the tool 0.1515 one way and the other way, and should end up at the 503 that I require. First thing I've got to do is make sure, because I've only rough machined these two faces of the crank webs, I need to equalize those about the center point there. So I'll touch off again this side and this side, see what the difference is, and I know which side is high, so to speak. Take a few thou off until they're equal about the center, and then from there on a few thou each side at a time until I get the right width, and then I'll focus on doing the journal. I did a rough measurement of that there, and it's 443, so theoretically I've got 60 thou to come off in total. Yep, that's the way I'm going to do it. Over to the lathe then. Alright, we'll see what we've got. This distance over the crankwebs. 753, 752 and a half, so 2.5 thou to go. Had a lot of fun and games with trying to turn this main journal here. I think a lot of the problem is down to the item being so long and slender and supported on pinpoints at the end, so this is tending to flex in the middle. I've tried various tool grinds and snugged up the tool as much as I dare to reduce the overhang, but I have to bear in mind when I get down to the crankwebs don't crash into the webs with the tool post. I think a lot of it's to do with it flexing. I've tried all sorts of things, different speeds and feeds of cut, and for this diameter actually the turning speed should be, you know, in the region 700 or so, but I'm way down 200, 250 to stop the chattering. If I go any faster than that, it's chattering, and chattering means rubbish surface. It's not too bad. It will polish to a better finish when I'm done. I'll get as close as I dare, and then I'll polish everything up. Okay, we'll take another cut. Very close now, about half a millimetre, 20 thou or so. We'll take a few more thou off. There we go. Yeah, 250. Can't go any faster than that, I'm afraid. It'd be helpful if I switched off my color feed. And there we go. It's the chattering's not too bad, of course, near the supported end, but the closer I get towards the centre of the part, you can hear the change in tone. But I'm so close now, I'm just going to persevere until I get there. It shouldn't be as bad when I do the other end of the crankshaft, because it's a much shorter length to turn. That's the theory anyway. You can just hear the noise now as it's just thinking about chattering. It's a bit annoying, but I'm not sure what else I can do with such a long, thin part. Anyway, I'll get back to you when I'm down to size and finish machining the side of that crankweb. Finish is not actually too bad. I'll just check for taper. I know there was about 1.5 thou. Switch that off first. Well, 1.5 thou difference. Where I got 14. 12.5. So the other end's down to size. Distance across the crankwebs is correct. Centre journal's done. It's just this last journal now and this one to the right thickness. So it's just more of the same, I'm afraid. Well, this is boring. I'll get back to you when I'm down to size. Right, that's the last part turned to size. I just got to get the width across the crankwebs down to size 750 and see what we've got. We have 772, so 22, so 0 the arrow. 22 thou. Okay. Anyway, I'll do the rest of it off camera and I'll get back to you. So the drawing shows the corners of the crankwebs to be sharp right angles. I think I'll put some chamfers on all four corners. So the way I've set it up, I've positioned the point of the tool right on the corner of a crankweb, lock the carriage and zero the y-axis or that away, and what I'll do is I've got the compound slide set over at 45 and I'll just wind in, take a few thou off at a time until it looks reasonable, and then make a note of the Y setting on the arrow, move across, do the same thing, touch off on the very corner with the tool, and do the same sort of thing. If I work to the same Y reading, I should theoretically get the same size chamfer, but we'll soon find out. Here we go. that's 20 thou. So if you think of a triangle, 20 thou by 20 thou, and the hypotenuse is then the chamfer. Let's have a look at that. A bit on the small side. A wee bit more. Take it up to 25 thou. That's better. I don't want a huge chamfer because that'll weaken that part of the crank. So 25 thou. So go across, I'll wind that back out. Go across to this one. Do the same thing. Yeah. Did it work? Yeah, I think it did. Yeah, they look to be exactly the same. That's good. Right, I won't bother filming it. I'm just going to flip this around end for end and do exactly the same thing on the other two corners, okay? Okay, all done. They look to be equal, a bit better than sharp corners. I think I'll leave it at that. I don't want too big a chamfer, as I say. Okay, next job, take it out the lathe and see if it fits. I bet it doesn't, so I'll have to come back and skim a bit, I suspect, but we live in hope. So there we have it. I'm not going to pretend this went together straight away. There was quite a bit of fettling to do, just a thou off here, thou off there. But it's okay. There's a little bit of a tight spot around the bottom there, but that'll run in fine. There's no, everything's built to pretty tight tolerances. There's no slack anywhere, so I'd rather it was like that than a rattling good fit before I even finish the engine. I'll leave this video as it is now. The next video I'll be using the tool that I made in the last video for turning the crank pins, which should be fun. What else? Counterbalance weights. I've been wondering what to do with these parts here. The drawing calls for a curved end, the same radius as these here. Don't really like that. The full-size engines had just a simple round end to match the crankshaft journal Might do that. I might design and make my own counterbalance weights. I mean, technically speaking, it's such a small model, it doesn't really need counterbalance weights. I'm certainly not going to be running at 5,000 RPM. It's not going in a model aircraft at the end of the day. I don't know why people run them so fast, but never mind. So jury's out on counterbalance weights. I'll wait and see. I'll turn the centre section out, and I've only got 3/16 width on the crank webs when I've finished, so that might be a little bit tight for the attachment holes for the counterbalance weights. As I say, jury's out. We'll wait to see. Okay, thanks for watching. Thanks for everyone who's subscribed, and I'll see you in the next video. Until then, take care. Bye now.